Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and in this video we are going to solve another GATE question. So this question was asked in the year 2019 for 1 marks, and this question is related to the fork system call. So let us read this question. The question goes something like this. The following C program is executed on a Unix or Linux system. Then the total number of child processes created is, that is what is asked. So here basically we have a C program and we are talking about the Unix operating system, Unix family of operating systems, right? So basically if you see this piece of code, what do we have here? There is a for loop, and this for loop is running from I is equals to 0 up till 9, right? It is less than 10, so I goes from 0 to 9. This is the for loop. And basically if the value of I is even, we are checking the, we are basically dividing I by 2 and checking whether the remainder is 0 or not. We are basically, this is a check that I is even or not. If it is even, then we invoke the fork system call. If it is odd, then we do nothing. The value of I will just change. And then this is the return statement. So this is basically a basic for loop where we have a condition that if the value of I is even, then only invoke the fork system call. Otherwise, do nothing. And this I, the value of I, it ranges from 0 to 9. So this is the piece of code. And as you can see, we have similar question asked in GATE related to the fork system call. You'll have a piece of code where there will be certain number of fork statements, and they will ask that how many new child processes will be created by this piece of code, right? So we have already derived the formula this for this type of scenarios. So we'll just use this formula. So before I show the formula, let me just quickly also recall about fork system call. So the fork system call is part of the Unix API, Unix system call API, right? It is used for creating a new process, right? And the way it works is that when a process invokes the fork system call, then the operating system creates a new process by duplicating or creating a copy of the calling or the original process, right? So here is an example of the fork system call. Let's say you have a process that is process A, and somewhere in the code of process A, there is the fork system call. So when the fork system call is invoked by process A, right, the control reaches fork, and what happens is that the control is immediately transferred to the fork routine inside the operating system, right? For any system call that you make, the control will be transferred to that system call routine inside the operating system. And what does the fork system call do? It basically creates a copy of this process. So process A, it duplicates this process and creates this process B. And process B, as you can see, has everything similar. It is actually almost an exact copy of process A. All the code that is being executed, the data that is being processed, right? Everything is copied from process A, except for a few minor differences like the process ID. These minor fields are unique in process B, different in unique process B. Rest everything is a copy of process A, right? And once the fork routine has made this new process, this child process, it returns in both the parent as well as the child process and starts basically resumes the execution from the statement after the fork. So this is how the fork system call works at a very high level. I have talked about this in great detail in one of the earlier videos. So having understood the fork system call, let us now come back to this question. So since this type of question is asked frequently, that given a piece of code where you have n fork statements, then like determine the number of child processes that will be created by that execution of that piece of code. So we already know that the relation is that if you have n calls to fork, or you can say if you have n fork statements in your piece of code, if you have n fork statements in your piece of code, then after that code is executed, the number of child processes that will be created in the system is 2 raised to the power n minus 1. And here is some examples, right? If the value of n is 1, then the number of child processes created will be 1. For 2 it is 3, for 3 it is 7, and so on. So basically this is the number of fork statements that are present in your piece of code, and this is the number of child processes that your code, when the code is executing, that will be created. So all we have to do in this question is that we have to determine how many fork statements are present in this piece of code. So as you can see, the number of fork calls is 5. How do we come up with this number 5? So you can see this is a for loop that the value of I is ranging from 0 up till 9, right? It will stop, it will not go till 10 because here we have a less than, strictly less than. So it will go only till 9, right? So here I have listed down the value for I, 0 up till 9, and I have highlighted the rows which are even. So if the value of I is even, then I have highlighted it in gray color. That is when you execute the fork statement. Otherwise, if it is odd, then you do nothing. So for I is equals to 0, 2, 4, 6, and 8. All of these are even. You can see we are checking the value of I is even or odd. Only when it is even, we are invoking the fork system call. So out of all these 10 values, 0, 2, 4, 6, 8, these are even, and here we are invoking the fork system call. Rest, when the case when the value of I is odd, we do nothing. So out of 10 we have 5 fork. Out of in 10 iterations we have 5 fork statements. So this piece of code is essentially equivalent to 5 fork statements, right? Okay, so now we can directly use the formula, and if the number of fork calls, if the number of fork statements in your piece of code is 5, then the number of child processes that will be created is 2 raised to the power 5 minus 1, which is 32 minus 1, that is 31. You can also verify this by executing your code, executing the code yourself. So let's execute this code. So let's start with the very initial parent process, right? Here we will maintain the value of I, the number of fork calls that we have all done, and the total number of child processes that have been created. So when the value of I is 0, then we'll have one fork call, right? So a new child process will be created, right? And as you can see, the number of child processes that we have at this point is 1. Then when the fork call returns in both the processes, now the value of I will be changed to 1. At this point, both the processes will not do anything. If you remember, when the value of I is odd, we do not execute any. You can see in this piece of code, when the value of I is odd, you do nothing. Here you can see for 1, 3, 5, 7, 9, you don't have to do anything, right? So after the first fork system call, when the fork returns in both the parent and the child, the value of I will change from 0 to 1, and in that iteration nothing has to be done. When the value of I is 2, then we will execute the fork system call again, and both of these processes, after creating new processes, you can see the total number of processes in the system will double. It will become 4. So how many fork calls we have done? We have done 2 fork calls, and the number of child processes in the system is 3, right? These are the child processes. This is the initial parent process, right? Now when the value of I is 3, basically now what happens after after the second fork system call is executed and the control returns in all of these 4 processes, now the value of I will be incremented from 2 to 3. At I is equals to 3, I is equals to 3, you do nothing. Then for I is equals to 4, all of these four processes will call the fork system call, and again the number of processes will double. It will become 8, right? So for I is equals to 4, the number of processes, total number of processes is 8, excluding the initial process. The total number of new processes that have been created, the number of child processes in the system is 7. Again, all of these 8 processes will return. When I changes to 5, the value of I changes from 4 to 5, they'll do nothing. When the value changes from 5 to 6, all of these 8 processes will invoke the fork system call. The number of processes in the system will double from 8 to 16, right? And again, all of the things that we said remains true. The number of child processes is 15. So till now, 4 fork system calls have been done, right? You could have directly used the formula 2 raised to the power 4, 16, 16 minus 1, 15. But we're just executing for the sake of execution. So now all of these 16 processes after the fourth system call will return. The value of I will change from 6 to 7. None of these 16 processes will do anything. Again, the value of I will change from 6 to 7 in all of these processes. So that is done. When I is equals to 7, nothing has to be done. When I becomes 7 to 8, all of these 16 processes will invoke fork. So now the total number of process will again double. It will be 32. And if you exclude this initial parent process, then the number of child processes in the system is 31, right? So we could have like got this answer, that is 31, without executing this piece of code, but just for the sake of more clarity, I did that. So if you have if you know the number of fork statements that are present, that basically that are going to be called, right? If you write this piece of code, kind of unroll this loop, right? If you unroll this loop, then the number of fork statements are 5. 5 fork statements will be executed. So the total number of child processes that will be created can be calculated using the formula, that is 2 to the power n minus 1. So 2 to the power 5 is 32. 32 minus 1 is 31. So the answer in this case is 31. So this is the answer to this question. So guys, this was it for this video. As you can see, in case of the fork system call, the questions that have been asked in the GATE exam are very similar, pattern based question. They give a piece of code which has a certain number of fork statements. You just have to figure out how many of these fork statements will be executed. Once you have figured out that number, you can plug it into the formula that we have derived, that is 2 raised to power n minus 1. But again, if they change the pattern of the question, then I would advise not to directly mindlessly copy that formula or use that formula. Always analyze whether the formula that has been created, this formula works under certain assumptions, right? So use that formula properly. Do not just blindly use it. Understand the rationale why this formula was created and how this formula was created. So this will help you to solve these kind of questions. Again, this is a pattern based question for the fork system call. Pretty simple. So guys, this was it for this video. Thank you very much for watching. I'll see you in the next video. Thank you.